Hello, Year 8. In today's lesson, we are going to be building on skills from not only yesterday's lesson, but also some work from last week. So today we're going to be looking at how we can add and subtract with mixed numbers. So I hope you've managed to get a copy of this sheet, but today's lesson, it isn't essential. There isn't going to be a huge amount of writing, so don't worry if you're working in your book and you've written the title and objective down. So the approach that we're going to be talking about today for adding and subtracting mixed numbers is not the only way that you can do things, but I think it is the best approach to minimize any mistakes. And the way that we're going to do these questions today is if we see any mixed numbers, we are going to turn them into improper fractions. So just like the maths that you were doing last lesson. Then if our denominators are different, we are going to have to turn them into fractions with common denominators, and then we should be able to add our fractions the same way that we were doing in the previous lesson. The final step might be then to take your final answer, which will most likely be an improper fraction, and just turn it back into a mixed number, and also to check that it's in its simplest form. So we're going to look at 4 examples, and very much the way that I'm going to set these out today would be the way that I would be expecting to see some working out for the questions that you try. So let's have a look at this first one. It says 3 4/5 plus 1 9/10. So the first thing that I'm going to do is I'm going to write both of these fractions as improper fractions. So I know that 3 4/5 is the same as 19/5. And I know that 1 9/10 is the same as 19/10. Now, do I have a common denominator? The answer to that is no. But this is a question where I can just change one of them to make the denominator the same. So I can turn them both into fractions out of 10. So this one already is. So that one can stay the same. What have I multiplied the numerator and denominator by? I've multiplied by 2. So this is going to be 38/10. Now I'm in a position where I can add these numbers up. So 38, add another 19 is 57/10. Let's think about that as a number of whole ones. It would be 5 whole ones with 7 remaining. So 5 7/10. Let's look at a second question, this time a subtraction. I'm going to do the exact same process, turn them into improper fractions first. Okay, so this one is 19/8. I seem to have a fascination with 19 today because this one is 19/12. It will not always be 19 on the numerator, I assure you. Now, common denominator this time for 8 and 12. That sounds like 24. So this one has been multiplied top and bottom by 3. So that is 57. This numerator and denominator is multiplied by 2. So this one is 38. Now remember, for this question, it is a subtraction. And 57 take away 38. Oh look, it's 19 again. So the answer to this question is 19/24. Let's see if we see any more 19s in the final 2 examples. So, got one more addition and one more subtraction. We're going to go through the exact same process, improper fractions first. So we've got 23 quarters. And this one is 19/9. Okay, my common denominator is a little bit more awkward, and we're going to see the numbers getting a little bit bigger on this one. Because my common denominator for 4 and 9 is 36. So I have multiplied 23 over 4 by 9. 23 times 9. Sounds hard, but if you do 23 times 10 and then knock a 23 off, that is probably the quickest way of doing 23 times 9. It's 207. We've got to do 19 times 4 for this numerator. Well, I know 20 times 4 is 80, so that one is going to be 76. Let's add this up. 207 plus 76 is 283 over 36. Now this is where the challenge is going to be, trying to turn this back into a mixed number, because how many 36s go into 283? So let's think about this for a moment. If you count up in 36s, I'm just going to do a bit of working out. I know that 5 36s is 180. If I have 3 more 36s, that would be 108. And that would be 288. I don't think I've got enough quite for 8 36s. So it's looking like 7 whole ones. So 7 times 36 must be 252. So if I've used 252 36, so how many are left to get up to 283? I believe that is another 31. So it's 7 and 31 36. That was a little bit nasty, but it got us thinking. Let's have a look at our final example. 7.5 is 15 over 2. We are subtracting 4 and 5/6. That is 29 sixths. Do I need to change both fractions? I don't think so. I can make them both fractions out of 6. So this one, times in top and bottom by 3, must be 45. 45 sixths, take away 29 sixths. Sounds like 16 sixths. Let's just double check by adding 16 back on. 39, 45, yep, sounds good. How many 6s go into 16? 6, 12, well that's 2, with 4 left over. So it's 2 and 4 sixths. Or as I'm sure some of you have spotted, that simplifies to 2 and 2/3. So those are the examples finished. If you go back to my instructions and follow the link to the PowerPoint, you'll be able to access these questions. Try and follow the usual order for level 1, level 2 and level 3. But remember, you are never restricted to doing those questions, so pick and choose what you would like to do. Remember, 5 minutes before the end, get out your different coloured pen. Check using the answers provided. Make any corrections that you need to in your different colour. And of course, if there's any difficulties, you can always ask using the Ask the Teacher channel.